So this is the homework question number 7. Okay. Here it is. So we have a reaction under standard conditions for all concentrations. Is it spontaneous? Okay. All right. So you need to really answer this question by determining whether E0 cell is what or what? Positive or negative, right? Because they said standard conditions, so that means let's just calculate E0 cell. And if it's positive, it'll be spontaneous. And that's because of this, right? Okay. Yes, ma'am. Okay. So we got to get E0 cell. Well, if we're going to get E0 cell, instead of going back and forth, let's just find the standard reduction potential table. What page is the standard reduction potential table on in here? Page what? 115? Oh yeah, there's one on page 115. Right? Okay. So, now looking at part B, we're going to have to, they tell us the overall reaction. Well, we can write it out anyway. Let's just write out our 2 half reactions. Do you see either half reaction here? Well, the Br minus goes to Br2. That one should be easy to find. Where's that one? Where's bromine? Oh, there it is. It's right under the... Now, as it's written, did anyone find it in the table? Did you find it in the table? Find it in the table. Do I need to flip that table, flip it in the reaction in the table, or not? Leave it alone? Flip it. I need to flip it. Right? Does everybody see it? Found it in the table, and it needs to be flipped. So that means I better do what to the little the E0 for it? I better change the side. Yeah. Okay, so let's flip that reaction. So I'll have 2 Br minus goes to Br2 and 2 electrons. And since I flipped it, negative 1.07 volts. Okay. So because I have to add up these 2 half reactions to get that overall reaction. I need one more reaction so that when I add them up, I get this one. Okay, I need something with oxygen, gas, hydrogen ions, and water liquid. Do you see it? It's the one that's in the boxed in. Great. Okay, so am I gonna leave it alone or flip it? Leave it alone. Good. Now, if you're seeing what I'm talking about, if you don't see what I'm talking about, you should stop me here and ask. So I'm just copying this from the table. We don't have to memorize this stuff. Okay, and it goes to 2 H2O liquids. Okay.
So why are we leaving it alone?
Because I need to add them up so that I get that overall reaction. That's why we wrote these 2 half, that's why we picked out these 2 half reactions, and that's why we're writing them the way we are.
Okay, but you were saying leave it alone, meaning don't flip it, right?
Yeah, don't flip it. That's what I meant. Because in the overall reaction, I can't jump that high. But oxygen gas, it's a reactant. In the table, oxygen gas is a reactant. H2O is a liquid on the product side. So don't mess with it. Because if you flip this, you're not going to get that overall reaction. Okay. And that was 1.23 volts. Okay. So if you want an overall balanced reaction, you multiply the top one through by 2, but okay. So you can check and make sure that you get the same overall reaction, but I'm sure we do, right? But you should have a negative 1.07 and a positive 1.23 is a positive what? 16? Positive 0.16 volts. Okay? So how would you answer, are we done or do we have to calculate something for part A? Are we done, Desiree, or do we need to calculate something to finish part A? You have to figure out whether it's spontaneous or not. So really, technically, we should do what? Calculate. We should technically calculate delta G. I'm not sure if the book accepts this as a final answer or not. But you know by looking at this equation that if you get a positive E0 cell, if this is positive, delta G is, geez, what the heck? If that's positive, delta G is negative, so it works. But I think they probably want you to calculate it. So maybe just pretend that, I don't pretend, I guess you should calculate delta G0 just to finish the story. So delta G0 would be minus, what do you put in for N? 4. F is how much? Do you remember F? 96,485 coulombs. E0 cell, positive 0.16 volts. So you do all this, and you get a negative number, negative whatever. And what units? What units do I put on this? Danielle, what units do I put on delta G? I don't know if it's much of a hint, but a coulomb times a volt. A volt is a joule per coulomb. The coulombs cancel. You just get joules. And energy is always joules. Just like W max. That's work. That's energy. You should get joules for that too. Okay.
So delta G is in joules then?
You can change it to kilojoules if you'd like, but you'd have to do the converting.
I was just making sure because like I'm used to seeing that, what is it, something of formation or something, how it's like in joules per mole or something.
Yeah, we probably should watch our units a little bit more because we have, well, no, we're multiplying it by moles of electrons.
I know that
So,
cancels 4 moles, I mean, what do you call it, 12 electrons.
I'm happy with joules. I'm happy with
I was just
joules.
making sure that was right because I always remembered G's being like in joules per mole.
Yeah, this is more like delta G for a reaction. We're almost kind of missing a little subscript here. We should have little RXN by this stuff, but we don't. So I'm just following what the book does.
That's good, yeah. 'Cause I got
So it's really not a Gibbs energy of formation kind of thinking. It's more like what's the change in Gibbs energy going from here to here. And, okay, so you get a negative number, so you say it is spontaneous. Is there different degrees of spontaneity? Or if you say spontaneous, that means it. Are there different degrees of spontaneity? Kind of a conceptual question. Naya, are there? Yeah, most definitely. If you have big huge negative 3,000 kilojoules versus negative 30 kilojoules. Huge difference. One's going to have a huge equilibrium constant. The other one's going to be, yeah, it's still spontaneous, but it's not going to be near as big. So, okay, so that's part A. Part B is, hey, before we go to do part B. Yes, Kelly? Because delta G is negative. That's how spontaneity is defined. All right, because of that negative sign. What's the final answer? Did you get a final answer? Thanks. Okay, before we move on and do part B, I want to do a little aside. W max equals minus NF E cell or something like that, right? These two equations both have little n in them. Do you notice that? They both have little n in it. The delta, the Gibbs, that's the one where the little n is the moles of electrons, right? Now they're both moles of electrons, but little n in the delta G is the moles of electrons that cancel in our reaction, right? Is that the case for W max? Now for W max, it's a whole different scenario. W is work. Can you do different degrees of work? Right? If you have a battery that has different amounts of chemicals in there, it could supply different amounts of work. Does that make sense? I mean, you could have more reactants, so it could do much more work. It'll last a lot longer than if it had less reactants. Does that make sense? So one would be more joules than the other one. That's this W max. And that little n has to take that into account and has to change. That E cell doesn't, because that's what you read off of the voltmeter. That F, that's just what number? 96,485. So that little n is the moles of electrons to do that work. And that's going to be changing on you. With this n, with Gibbs, no, that's like my height. From here down to there. You know, it doesn't matter how many of them there are of me. My height is this. It's a change in, yeah. So, but we'll stick to in one instant in time. So this n is the n that cancels in the half reactions. Gibbs is kind of like, remember when we were drawing those, this is probably getting too involved for you, but we drew these, in Gen Chem, we drew like an exothermic reaction. We had the products way up here in energy and the reactants way down here. So you're talking about a difference in energy of the two. It didn't matter how much you had. It's just, right? That's their difference in energy between reactants and products. That's what Gibbs is all about. Oh, this is going to be spontaneous or it's not going to be spontaneous. Okay. So W max is the amount of work. So you have to get that little n. So that little n, and they never, ever in a homework question do they say, oh, to get this little car to go from this little battery-operated car to go from one end of the table to the other end of the table, it sucked up 908,000 moles of electrons. No. They told you it consumed 1 gram of zinc. It produced 2 grams of copper. Right? And you got to convert that to moles of electrons to put in here. And the more it consumed in material, or the more it produced as a byproduct in that electrochemical reaction, right, the more electrons were involved. So that's the game that we played with that. Anyway, I just want to see if I could try to clear that up a little bit. If the hydrogen ion is adjusted so that the pH is 3.6, what value will E cell have? And will it still be spontaneous? So you're supposed to keep everything else standard conditions. So how do you calculate these E cells? We have to use whose equation? Nernst. So let's write our Nernst equation. E cell is E0 cell minus 0.059, I forget, 1 or 2 or something, all over n, log of, what symbol? Q. Here's another question. When do you write K? At equilibrium, yes. But what else? So if you want to change this equation, make this say K, what else do you have to change? Make what? Make the little voltmeter read 0. So that means what has to be 0? E cell. So when you want to talk about equilibrium, erase the Q, make it a K, and erase E cell and make it a 0. Okay, but that's not what they're asking. They're asking, They're asking, is it spontaneous? So we have to do the same thing. We have to use delta G is minus NF E cell, but we got to calculate that E cell, right? We got to get it from the Nernst. We have to calculate it. Because no longer are they at standard conditions. Before they were, so we could just use E0 cell. So, well, we already did E0 cell, so that part is done. We already got the E0 cell part. What is it? We said it was 0.16 volts minus 0.0591. And what's N again? 4, because 4 canceled. Thank you. Log of products over reactants. So we got to look at our cell to do this. Okay. Products over reactants. So that's H2O. Does this show up in our Q expression? No, because it's a liquid. But the bromine is a liquid too, isn't it? Shoot. Are we going to have anything to show up? We have a 1 in the numerator. Something better show up. What's the reactants? How about O2? Does that show up?
Do we have the partial pressure of that, though?
Okay. Yes, we. So O2, you can write it this way. Well, let's write the expression first. And then we'll answer Ricky's question. O2, what else should be down there? Hydrogen ion to the 4th power. Anything else should be down there? Bromide to the 4th power again. Okay, what's kind of nice is the standard condition stuff. So let's see if you remember what that's going to be. So my E cell is positive 0.16 minus 0.0591 all over 4 log of 1 divided by, okay, they only changed one thing. They changed hydrogen ion concentration. So everything else needs to be what? Standard, which is, for concentrations, 1 molar. For all gases. Ooh, bonus points. He didn't say 1 ATM, he said 1 bar. Yeah. So that's what everything is. So 1 bar. Oh, we got to figure out the hydrogen ion concentration. We got to figure out the height. They said the pH was what? 3.6. So if the pH is 3.6, how do I get hydrogen ion concentration? How do we do it? Someone said it? Ida, what'd you say? 10 to the 10 to the pH. Well, 10 to the negative pH. 10 to the negative pH. So 10 to the negative 3.6 will be my hydrogen ion concentration. So since some Glorianne wanted me to shut the lights off, I do not have a solar-powered thinger. So what is 10 to the negative 3.6? 2 point what? 512 times 10 to the negative 4. And it has to be raised to the 4th power. Okay, so you got to figure out this logarithm, right? And take it times the negative 0.0591 divided by 4, add it to 0.16, and you get so many volts. Hopefully you get, what did I say? Negative 0.06 volts. Psh, I don't know. That's what I came up with. I don't know when. Is that right? It works out. Okay. So for me, if this was an exam question and they're asking, is it spontaneous, I don't expect you to go calculate delta G, because I think by this time you understand that if E cell is, if you want it to be spontaneous, E cell has to be positive, right? So this is negative. Now it's close to 0, but it's definitely negative, so this would be non-spontaneous. I don't think you need to go and calculate delta G, only if it asks for it. So did I lose you anywhere along the way in there?
But the Br minus concentration is 1 because of standard condition?
Yeah, because they said, that's where the English makes it look tough. But they only changed pH, so you just have to assume everything else is still standard conditions. Because you have nothing else to go by. Okay. Is there another homework question that you'd like to see work through?
How about 4?
Number 4. Oh, sorry, 4. Yeah, there's 4. Okay. Cell potential is 0.475. What's the pH of the test solution? Let's pick on Andy. What's the pH? That means we have to really find what in the end? Concentration of hydrogen ion. We got to find that. Okay. So we need an expression with a concentration of hydrogen ion in it. I don't know. Marlena, where would you start on something like that? The Nernst equation, exactly. Right? It fits perfect because they told us what the reaction is. It may not look like it, but they did. They told us E cell. Okay. And once you start with the Nernst equation, it kind of tells you everything that you need to know. Right? You need to figure out what E0 cell is. You got to figure out what N is. Right? And that's a very, that N, that's the same N that goes in the delta G equations. It's the number of moles of electrons that cancel. Okay, these are potential ideas. It's not a how much work can you achieve type of question. And then get your overall reaction so we can write the equilibrium constant expression and put it in for Q. Okay, so pretty much all I do for these is I recognize where the arrows go. Okay, and I can find them in you're going to have to find them anyway in the standard reduction potential table because you have to look up what E0 cell is. So you do that on page 115. Find these things. Zinc goes to zinc plus 2. And that's positive 0.76 because it's written opposite. Right? You have to flip it from the table. Find the hydrogen electrode, right? You recognize the standard hydrogen electrode? It has that platinum in it. This is the one that has the 0 volts. They're measuring all potentials with respect to it. And so hydrogen ion pretty much just goes to H2. But they have 2 H's, so 2 here. I have a positive 2 now. Let's see. Hey, my electrons will cancel as is, so pretty much just add stuff up and I'll have my overall reaction. Because those guys are done. Don't have to multiply through by anything at all. So the reactant side, I'll have a zinc. It's supposed to say solid on it. A couple of hydrogen ions. That's it for the reactants. Product side, add that stuff up. I'll have 1 zinc ion and hydrogen gas. So I have pretty much everything I need to write that Nernst equation. So how would you write that Nernst equation? Oh, Randy, how would you write that Nernst equation? 0.475 equals 0.76 perfect. Capital P, H2.
Divided by the concentration of the hydrogen ion squared.
Perfect. Okay. And now we are solving. Andy said to solve for the hydrogen ion. So we just got to put in numbers for the zinc and the hydrogen pressure. Hydrogen is 1 bar. Zinc is 0.85 molar. Solve for hydrogen ion. Take the log of it. Technically the negative log of it, and you should get an answer.
What's that? ATM in bars is 1.01325?
They said it's 1 bar, so we don't have to worry
Oh,
about
they
it.
said it's bar.
They said it's 1 bar.
Oh, I'm sorry.
If it was 1 ATM, then you'd have to write
Okay, so
1.01 or something.
we do have to convert it, so it's going to be 1.01.
But I have it in bars. Maybe you have a different one.
Okay.
Maybe you have a different one. I just erase it and write a bar.
Okay.
But technically, if it was ATM, you'd have to convert it into bars. And like you said, I think 1 bar is 1.01.
No, the other way around.
The other way around?
Yeah, 1 ATM.
Oh, 1 ATM is 1.01 something 325 bars. So if you needed that, I'd tell you. Okay, but that's getting a really technical. But you could have helped all those physicists out on that physics forum if you'd know that. Okay. Hopefully you get. What's the answer for number 4? 4, I got 4.88 as a final answer.
Yeah, I got 4.85. I guess you didn't. I know we got like a little bit different.
Okay, fine. 4.9.
Well, not for this one. I was saying we're on the answer sheet. I think we must have got something different for number 1.
Okay.
Was it number 2?
So when you're solving for that, I would bring the 0.76 over first, right? Then I'd multiply it by a -2, divide it by a 0.0591, and whatever you get, raise it to the 10 power. After you raise it to the 10 power, you're going to have to flip it, divide it by 0.85, take the square root. Or you wouldn't divide it. You'd multiply it by 0.85, I guess, not divide. Did you get 4.9? Yeah. The P is just going to be 1, yeah, because it's 1 bar. And that's in the cell, and the other one's 0.85. And the only way you get those numbers is from the cell description. The cell notation tells you those. Andy, is there another homework problem or in here you'd like to see? Oh, it's 2:20. Man, we don't want to take that. We don't want to take that quiz, right? But we can go through it. Let's go through a game plan for number 3. Okay, we're not going to have time to solve it. But okay, so what you do is whenever they're asking, they give you a whole bunch of chemical components, okay, and it tells you, okay, well, what reaction is going to happen? The standard reduction potential table is your guide. It's your answer. Because it tells you what reactions are more spontaneous than others. And that's all you got to do. You got to figure out which reactions are going to be the most spontaneous. So you identify half-cell reactions that involve these, okay, that are plausible, that are possible. Okay? And in this case, it tells us the hydrogen ion concentration. So you can't rule out ones that involve the hydrogen ion because it told you you have appreciable hydrogen ion. So you find the half reactions that involve all of these, and then you add them up so that you get the most positive voltage. Now, there might be more than one combination, but the one that's the most positive is going to be the most spontaneous. It's going to happen the most. It's going to be the most appreciable. Okay? So that's the game plan. Make sense? So I think we should take the quiz. I'll give you 10 minutes. All right. So hurry up before you get it out of your short-term memory. Poor Kimberly has no short-term memory, so you should be happy. Life could be worse.
I had to take